Good morning, everyone. In the previous sessions, we started the collection framework. Right? In the collection framework, also we completed that list interface and the list interface types of vector, array list, linked list, and stack also. Right. Today we are going to discuss that queues and sets. Okay. Firstly, you have to understand the what is a queue. Before we studied that stack, right? What the stack will do? The element which was last entered, which will be comes first out, right? Like the way normal queue, imagine like a real world queue, like that your queue also like in suppose it is like a queue, it will follow the principle of FIFO, which was first in it will be the first out, first in will be the first out. That means here entry point and exit point not the same, right? Entry point and exit point not will be the same. It will be the entry, it will be the exit. Right, here your queue follows the FIFO లేదా or last in last out Lilo. Both are the same principles, right? Which was first in, it has to become first out, like a queue process in the any ticket counter or anything like that. Here also your queue will follow like this, and in this queue also here we have a types linked list queue, linked list queue, and priority queue. This linked list queue can be act as a double-ended queue also. Double-ended queue is nothing but it can perform insertion and deletion operations from the two ends. It was a front end, it was a rear end. We are calling it as. If the insertion and deletion, normally the queue performs the operations from exit operations from the front end, insertion operations from the rear end. Okay, so from back end. Like way, if both ends perform like a entry and exit points, that means in the both ends you can perform insertion and deletions, then it will be the double-ended, two entry points and two exit points. It will be the double-ended queue. By using the linked list, you can perform the double-ended queue. And priority queue is nothing but it's not based on the priority you are assigning to your values. Based on the priorities you are assigning to the values, that will execute first or it will come first. Suppose I have a set of elements of 10. In the 10, I am particularly assigning one with the highest priority. Then it will come first. Then it will come first. Like the way we'll observe that, right? First, this is the concept. The queue, what it will do. Right? We'll move to the execution part. I am creating one class to perform the queue operations. Okay, normally how can I create a queue? Is a queue has a interface. Queue is an interface. By using this queue, suppose I want to store the only the integers, q1 equals to new import java.util.q. Correct. Normally in the queue, how can we insertion will be happen? Here insertion uses the two types of methods. Insertion uses the two types of methods here. First one, by using the add. And the second one will be the offer. These are the two methods helps to working on insertion operations in a queue. But the difference here is, if add will be the success, that means operation is success, operation of insertion is success, it will execute. Or else throws error. But in this offer, operation is success, it will return true, it will return true. It will return true or else false, but not throws any error. Okay, suppose I have a q1, right? In that q1 I'll try to add one element, q1 dot add of 4 of q1. Next, q1 dot add of 7, and sys out of print the q1. Okay, now it will print here my q1 will be the only 4, here my q1 becomes 4 7, 4 and 7, right? Right, 4 4 and 7. Suppose if I try to go with the offer method, offer, suppose my queue is integers, right? Suppose I'll try to add the character, then it will equals integer type. Suppose 1. If I print this, q1 dot offer of, if operation is true, it will return true, or else it will return false. True and false. If I again print here my q, q1, then it will return a 471, right? 471 it will print. Four seven one, right? Offer method also doing like that add only, but the difference is offer method returns true or false. If the operation is success, it will return true. If operation fails, it will be the false. But add is not like that. If true, that means operation success only, it will add an element, or else it will return a false. Okay, it will not return anything, it will return an exception, illegal state exception, like that. You can observe this by using delete methods, right? Now we observe that insertion, right? Now we can move with the deletion operations. In the deletion also we have the two. One was remove, second one will be the poll. Same like above add, same like above add, but difference is removing the element. Above add, same like above offer, but they perform insertion, it will perform deletion. Okay, suppose if I'll try to do q1 dot remove off, okay, q1 dot remove off, sys out of q1, right? After removing one element from my queue, then seven and one, the first what was inserted, it will be deleted first. Okay, right? Like the way I'll perform the q1 dot one again two times. Okay, q1 dot remove and q1 dot remove. After this my queue will be the empty. Why? Because here only I have the 7 and 1, one removing, one only, here empty queue, empty queue, right? Then I'll try to perform a q1 dot remove again. Okay, q1 dot remove again. No such element exception, removes first, remove. Okay, why? Because after deleting this all q1 dot remove and q1 dot remove all the things, it will be the empty. In the empty list, what I have to remove, it doesn't know. Then suppose if I do q1 dot poll, okay, here I can perform sysout, then I can observe what it will return. Null. Why? Because my queue is empty, but I am trying to remove an element from my queue. Then poll returns, this poll method returns that false or null, but the remove method returns the exception. That is the difference, but both will do the deletion operation only. But this is the difference between queue and a remove method. Okay, like this you have the add all, remove all. Also suppose you want to know the peak element here, peak, then before removing, this out, q1 dot peak off. What is the peak element? 7. Okay, suppose if you this 7 is removing element from the q1 dot poll, removing element from the q1 dot poll, and this is the peak element. Peak element is the first element in your queue, that means which was tried first to come out from your queue. Okay, normally you have the add all method, remove all method, like what are the methods you have in the vectors and the arrays also, but they are following the principle of first in first out, which was in the first, it has to come first out from the queue. It was by using a linked list, and another thing is there by using the priority queue. Priority queue, priority queue is nothing but it will be maintain the order on the basis of priorities you are mentioning for your elements. Okay, suppose same the q1 dot add of 5, q1 dot add of 7, q1 dot add of 15, q1 dot add of 1. Now I can print my q1. I can observe the order it will maintain. What is the order it will maintain? 1, 5, 15, 7, but my order of insertion is 5, 7, 15, 1. The element, which element you are providing, that is the order it will maintain. That means lowest comes high priority, lowest will be with high priority, lowest element with high priority. That means 1 has the highest priority, 5 has the second highest, 7 has the third highest, 15 has the last highest. Suppose if I perform that q1 dot poll. Suppose if I perform q1 dot poll, then it will return 1. But according to the queue principle, 1 is inserted at last, but it will come first. Why? Because it is a priority queue. In that priority queue, based on the priority, it will perform the operation, and the priority is also assigned lowest value with a high priority, highest value with a low priority. Okay, lowest values can have high priority, highest values can have low priority. This is the priority queue. Normally it will not maintain the insertion of the order based on the priorities or mentioned in your queue and perform the operations, right? Why? Because normally the queue operations helps you to achieving on a CPU task. In the CPU task, some operation has the highest priority. First it has to be execute, like that. Okay, this is the queues. Next we'll go with the sets. All the methods what you are applicable in the linked as linked set queue, like that you can use here also. Okay, next we'll go with the sets. First, what is a set? Means set is a collection which not allows duplicates. Set is also like a one array, but the condition here is it will not allows, but it will not allows duplicate elements in the collection. Okay, not allows the duplicate elements. And these sets also you can be implemented by using the normal set interface and linked hash set and tree set. Linked hash set and tree set. What the things you can perform with that is first, how can we create a set? Is set is an interface. Set is the interface to do that. Set s1 is equal to new set of, it will be the hash set import java dot util dot star. Okay, this is the way you can create a set. Suppose you want to mention which type of data you are storing in your set, then you can mention here like this. Suppose I want to store only the integers, then integer hash set. Here you can mention empty generics. The first way of set creation by using the hash set. Okay, and what this hash set will do, hash set not allows the duplicate, allows duplicate, and may or may not be maintain order, may or may not be maintain order. That means not at all any requirement for maintaining the order. That means suppose normal methods what you are applicable or using in the vectors and all, those are applicable here also. Suppose s1 dot add of, okay, s1 dot add of 1, s1 my set 1, right? Like this I can do for the multiple times. Here I can go with the 5. Here I can go with the 7. Here I can go with the 11. Okay, 1 5 7 11. Okay, and I'll observe it will maintain any order or not. It will maintain an order, but may or may not be maintain any order. There is no particular condition to maintain order. Sometimes it will not maintain an order, but it will not allow duplicates. Suppose if I try to add a s1 dot add of already 7 is there, right? I'll try to add the 7, then it will not throws any error, but it will not add an element to that s1 also. Once we will observe of s1, it will not throws any error, and also it will not add the element to that existing collection also. Basically what you have to understand here is set is a data structure or a collection which helps to maintain the unique elements in a single container, and may or may not be maintain order. Suppose you one insertion order, it will not maintain. Sometimes it will maintain. Suppose I can do I'll do one thing. For int I equals to 0, I less than or equals to 15, I plus plus s1 dot add of I, right? And here I can print sys out of s1. Normally it has to print 0 to 15 values in a container. I'll see. Maintaining the order. I'll do one thing. I want the case it is not maintaining the order. We'll do one thing. Now we can perform remove. That means I greater than 0, s1 dot of I. In the remove you have to pass an value which you have to remove. Right? If you observe here first what I do, I'll remove the elements. That means first I am adding the 15 elements into that 0 1 2 3. Do one thing. This sort of s1, and the same thing right. If you observe 0 1 2 3, first 15 elements will be added into my set. After that I am removing these 10 elements. then my order will be the 11, 12, 13, 14, 15, right? After again I'm trying to adding the elements, then what would be my order? After 15 it has to be add 0, 1, 2, 3, 4, like that it has to add, but it will comes in the front. That means it will not maintaining any order, right? But it will stores the unique element. That is, you have to be understand here. Remove is the method to removing the element, add is the method to add the element, and you have the methods of size to know the how many elements in your set. That means length of your set. Length of your set. And is empty is method to check your set is empty or not, to check set is empty or not. And you have a method of clear, remove entire set of elements. Entire set of elements, suppose and size is empty, clear, remove all, add all, like that. What the methods you are perform in the vectors and the array list, that will be applicable here also, right? But the thing has set, what it would do is it will not maintain order and stores the unique elements. Normal set means stores the unique elements, but here the thing, the difference with the all the set is it not maintain any order. Okay, not maintains any order. Okay, like this way we have another set. It is linked hash set. The difference between hash set and the linked hash set is it will maintains the order. Okay, linked hash set maintains the order and it stores the unique elements. Why it will maintain the, what the linked hash set or linked set will do? Normally stores one element at one memory location and mapping with the other. If it not maintaining the order, then it will try to lose the data. Suppose imagine the thing, I have one data here, one data here, and one data here, and one data here. First I am storing this, after this I am storing this one. Okay, after this I am storing this one, that means link is between them, and after this I am storing this one, right? If here I am not maintaining the order, suppose if I am delete this, then I can lose this data, right? These two elements data also. Why? Because I am removing this element. This element doesn't know about this element and also this element, right? This element not aware about this element and this element. If I remove this element, we are losing the data of this element information and this element information also. For that purpose, linked hash set maintains the order. That means suppose if you are removing this element, it will stores address in this location and maintaining the order. Okay, that means which element you are adding into the linked hash set, it has to maintain that order. Suppose the same thing here we are using the hash set, right? Then here we can go with the linked hash set. Okay, linked hash set, and see what the operation we do for the hash set we can do here also. And we observe, suppose insertion of data 0, 1, 2, 3, 4, like that, it will goes for the 15, and we are removing the elements. But if you observe again, I'll try to adding the 15 elements. 0 is not in my set, so it will add the element at last, and 1 is after that, 2 is after that. That means what was the order you are maintaining with the insertion, it will maintain the order. In previous, what it will do, it will add the all elements before this, right? But here it will, what are the order you are maintaining to insertion, it will maintain that, and the operations will be the same. What you are using for the hash set, those are applicable here for the linked hash set also. Okay, and all the operations are the same. The concept is, the thing is, the order it will maintain. Okay, it is linked hash set, and another set is there, it was the tree set. And the difference between these three set is, tree set always stores the element in a sorting order. Tree set always stores the elements in a sorting order. Suppose, okay, here I can declare the set with a tree set. Okay, suppose I want to add s1 dot add of, suppose first I'll add 12, and after that s1 dot add of 5, and s1 dot add of 1, and s1 dot add of 10. Okay, if I print here, s1, what the order you can give, but it will stores the elements in a ascending order or the sorted order. Okay, first I have to enter the 12, and after I am entering the 5 and 1 and 10, but it will stores in the order of 1, 5, 10 and 12 and 12, right? This is the thing with the tree set. Tree set stores the elements in a sorted order. Linked hash set maintains the order of insertion. Hash set stores the only unique element, not maintain the order. But the common thing with the three types is, stores only unique elements. That is the common in the three types. But the difference is, tree set will be stored with a, what it is, sorting order. Linked hash set with the maintaining the order, and hash set not maintain the order. That is the difference. When someone asks what is the difference between the types in the sets, okay, this is the normal sets operation. Normally, why you are learning this all the collections is, suppose you have a data, you have the n number of data. Suppose if I am giving the data int array is equals to, I am giving one set of data to you. I am in the giving in the form of a array, but what I am said to you is, I want only the unique elements from this array. I want only unique elements from this array. Then what you can do? You can simply go with the one set operation, any set. Then you can return the, data, unique data. But suppose my query is, I want the unique data, but I want the order. That means, suppose here unique data means 1, 2, 3, 4, 5, 10 and 8. I want this order. Suppose if I go with the normal hash set, set s1 equals to new hash set. Okay, new hash set I am created. In this first, how can I traverse in my array? for int I equals to 0, I less than or equals to, sorry, I less than arr dot length. Length is the method, to represent the how many elements in my array, right? And s1 dot add of what, arr of I, right? And sysout of s1. What the order it will maintain? 1 2 3 4 5 8 10. Normally in a sorted order it will always giving, but I want disturb any order in that, then I can go with the linked hash set. Linked hash set, then it will give 1 2 3 4 5 10 8. Right? Suppose you want it in a sorted order, then you can go with the tree set. Okay, normally by using this set or the any collection framework methods, you have to perform this type of questions and the problems. Suppose someone said you can read the elements and store it in a framework, they don't mention any size to that framework or size to the element reading. Okay, then you can go with the list interface, create an array list or a vector, then read the elements and add the element into the list. Suppose here the thing will be the, you have a two strings, but you want to find the unique characters. That means what are the characters in the set 1 or string 1 are in the string 2 also. Suppose I have the str1 is equals to hello, string str1 is equal to hello, and string str2 equals to hi, right? Now I have to display what are the common characters in these two strings. Okay, this is one type of question. I want to display the common characters in the two strings. What is the common characters in the string? H only, right? H only. Now how can I do that? Simply store one string of characters, store one string of characters in the set and check other string of characters in that set or not. Suppose first I store that str1. How can I traverse in the string? Suppose if I try to print like sys out of like array str1 of 0, then it will comes no, right? By like array you can't access the characters in the string, then how can you access? Using a caret function. Caret, in that caret you can pass, suppose simply like str1 dot caret of 0. Okay, caret of 0, then it will prints the h. H. But here I want to perform by using the sets, right? Uh, Hammer. Okay, hammer. Now I can declare one set. Set S1 equals to new, okay, new hash set, new hash set. In that set, what I have to do is for int I equals to 0 to, how can you find the string length? str1 dot length, right? And I plus plus sorry, I less than or equals to str1 dot length I less than or equals to str1 dot length of, and s1 dot add of, what the element I have to add here? str1 dot character, character of I, okay, and it will store the unique characters, it will store the unique characters. And now what you have to do here, what you have to do here, you want to display the unique characters, or that means common characters in your two strings, right? If I do like this, it will store only the unique characters in the str1, but I want to compare the two strings, right? Then how can I do that? I can take another set, set s1 equals to, or s2 equals to new hash set, in that new asset what I have to do is for int I equals to 0, I less than or equals to str2 dot length I plus plus, and s2 dot, suppose normally if you want to check one element is in the set or not, what is the method you have? Contains. Contains is the method can check the element exists in that collection or not. If s1 dot contains, s1 dot contains of s1 dot contains of str2 str2 dot character of I, suppose that character, suppose that character is in that what I am doing here, first I am storing these characters in a set, after that going through the every character I am checking that character is in my set or not. I am checking h is in that set, or suppose here what will be the s1, s1 contains h e l and o, right? Here my s1 contains these four elements. Now what I am doing is I am checking this h in my s1 and a in my s1, m in my s1, e in my s1, r in my s1. If it is in it, what I am doing, I am adding to the s2 dot, I am adding element to the second set. What I have to add? str2 dot caret, of I, right? Now you have to print only the unique characters, right? 6 out of S2. S2 contains the common characters in the two strings. It has to return HE. Index out of bound exception. Why? Because always your I less than the string length. E and H. Normally it gives in a sort order. So E and H, E, F, G, H, right? Like this, you can do n number of problems like this under the collection framework. And in the collection framework, we are left with one topic. It was the maps. What is the maps? Is normally maps maintains the key value page. Like your object, suppose name equals to some value, age equals to some value. Like that, maps also can do that. If you observe in a Python, it will be like a dictionary. Okay, maps like that. We'll discuss the maps tomorrow, right? This is the sets and all the collections till that, and you have to practice on it. Thank you.